integrals can be defined as area under curves, so areas, and the other way you can kind of define it would be the sum of all values of x for a given region or domain, even better. Right, you'll see, like, we'll see stuff later on where you'll have something like this. Like, everybody knows that, force equals mass times acceleration. If you wanted to know but what if acceleration is changing, right? What if acceleration is given by, let's say, 2t squared? T is time, right? Let's say acceleration is given by 2t squared plus t. Well, if time, this means that acceleration is changing with time. So if I wanted to figure out, let's say mass is constant, if I want to know the total force exerted between time 0 and time 2, I would take that integral. So that is an important conceptual idea of what we're trying to do here. We're trying to add up all of the values, in our case here, from 1 to 0 of these values. Okay. So, all right, let's say y is that. So always with integrals, I find it's good to change the radical expression to be a fractional exponent. Negative fractions are fine. And why do I do this? Well, because it's just easier to see that now this can be, I'm in a situation where a u-substitution is a good method here, because the x squared is going to play well with the x1. When I take the derivative, it's going to do nicely. So this is a good candidate for u-substitution immediately. Again, this is the key point here, right? If you're not able to eliminate your x's or the other variable, then you can't proceed. Something else would have had to have been done. Right, in this case, it's nice. It cleans everything up, right? We can also get rid of the 4 here, but that's not the important part. The important part was getting rid of the x. It's getting rid of the other variable. If that's not able to have been accomplished, then we would have had to have gone back and tried another strategy. Because it would have gotten in the way of our ultimate goal of getting to this situation here. Right, this again is the ultimate goal of the integration process, or the setup, is make it look like this. Have all the work that shows that you've turned it into this, and then we can take our integral. So we add 1, so plus half. Now, instead of just writing plus c, because it's a definite integral, we do a straight line, and we say, okay, now it's bound between 1 and 0, which means that I need to, so let's just put our x value back in there. Still substituting these values, right?